If I'm not sure if you have also noticed that when we're talking about solving for x using laws of logarithms and solving for x using laws of exponents, we said that these questions of this type, or questions regarding the topic of logarithms and exponents, will contain about 16.9% in the test. So it is also worth it to actually take some examples on these particular questions. So the first one will be, we want to solve for x using laws of logarithms. Let me just write them down, just few of them. There are only 4. Okay, I'm only gonna require 4 from you. I don't want many of these laws. We said that if I have log of a of x times y, I am supposed to get the same answer as log base a of x plus log base a of y. And then if I have let me cut this off. If I have log base a of x divided by y, I should get the same answer if I take log base a of x minus log base a of y. The third one is saying if I have log base a of x to the exponent b, I can always bring down this b in front and still get the same answer if I have this b log a of x. And the last one will be, whenever I have log base a of x, this is always going to be the same as long as I have a base bigger than 0. I take this number x inside, I place it inside here, and then I divide by log base b of a. As long as this b and this b is the same, and this b is bigger than 0, this is always going to be actually true. So let us actually try and see if we can solve for x in each of these scenarios here. And then, of course, I don't know how to do this. Let me do this. Okay, I want to solve for x here, solve for x here, solve for x here, solve for x here, solve for x here. We'll be using laws of logarithms. I don't know how can I write here because I want to remember these problems. Okay. The first one was, these are the solutions, of course. I have my solutions here. So the first problem is saying we have log base 2 of x minus 3 and then is equal to 4. Of course, this is what I would always suggest. Because these videos tends to be too long unnecessarily. What you do, pause the video, do this problem, finish it, 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 and do these problems, finish them. And then after that, you can fast forward the video to the solution and see what you're actually getting. Because when you're preparing for the exam, most of the time you don't have time. So just fast forward to the solution and check if it matches with yours. If it matches, move forward. If it doesn't match, then you need to check that part. How did we get the answer? But if it matches, then move forward. You don't have to waste time. We don't have time. But of course, in all other videos, the one that I've just posted and the others that I will post, you can always do that. Instead of wasting a whole hour looking at everything, some of the things you already know. So let's continue with this. Looking into this here, you can see that we want to solve for x which is inside here. Of course, every single time when you have something of this type, you must always remember this one law, that a base will always gonna be the base here. So I'm going to have a 2 here. So this 2 was the base in this equation. And then what was on the other side, this is what I'm actually doing here, so that if you don't remember, if I have a number equal to a base raised to an exponent, this can always be the same as I have an exponent equal to log base a number, right? So a base is always gonna be the base. But now, if the subject of the formula is the number and we're happy with it, we always go with that. But if the subject of the formula is in the exponent, we want to make it the subject of the formula exponent, we always bring the exponent down, and then we have this. But if the subject of the formula is in this equation is inside here, we always wanted to make it on the other side. So here, what is inside here is what is considered a number. So we want it to be the subject of the formula. So we have x minus 3 is equal to 2 raised to, this number that was sitting alone is supposed to be an exponent. So we have a 4 there. So if you look into this, I have x minus 3 is equal to 2. 2 times 2 is 4. This is 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. So we have a 16 here. So our x here is going to be 16 plus a 3, or x is equal to a 19. So that's how easy this thing is. And then secondly, we have number 2. Our number 2 was saying we have ln of x plus 1 minus ln of 2 is equal to ln of 5. Now, everything that have an x is contained in this ln here. Everything that does not have an x, I want it to be in other side. So we'll end up having ln of x plus 1 is equal to, I'm taking this to the other side, so the sign is going to change. I have ln of 5 and then plus ln of 2. I want us to talk about this ln here because a ln function, we always know that it is the same as log base e. So this is going to be log base e of 5. So whenever we see ln, ln is a natural log. So all the laws about the logarithmic functions, they also apply with the ln function because it's under the log. And then if you look into this, we have a plus here. Whenever we have a plus, we always go to these laws and remind ourselves that there is only one law that have a plus here. It means that whatever was inside, I can multiply it, but I keep the base. So here, I will end up having ln of 5 times 2 because I have a plus, so multiply this and that. And then this side, I still have ln of x plus a 1. And if you look carefully into this, this is going to be ln of x plus 1. And this side, I still have ln of 10. 5 times 2 is a 10. And if you look carefully into this, you will find out that I have a ln function and a ln function that side. And a ln function is an increasing function. So if these two ln functions are equal, whatever is inside needs to be equal. Or x is just going to be 10 minus a 1. Or x is going to be equal to a 9. So if you plug in a 9 here, you will find out that you will end up having a 10. Minus means divide. 10 divided by 2, you end up getting a 5. So this is the value for this particular question here. And then the third question is saying that we have log base 5 of x and then plus log base 5 of 4 is equal to 2. So if you look carefully here, I have this base and this base are the same, and you have a plus here, which means that I can always have a log. The base is the same, I keep it, but because of a plus, I multiply this with that, so we'll end up having 4x is equal to a 2. And if you look carefully into that, we have this thing that is inside. We wanted to make it the subject of this formula here, and this 5 was the base, so I'm gonna raise that. This is going to be an exponent there. Of course, we use the same thing here. Keep the base as it is. This inside here is the number, and then that one is supposed to be an exponent. And if you look carefully into this, 4x is the same as 5 squared is 25, which means now our x is going to be 25 divided by 4. That's how you do this. Combine these two, and then we go to the fourth one. The fourth one is saying that I have 3 to the exponent x minus 1 is equal to 7. Right. Of course, I still want to solve this using laws of logarithm. And if you look into this, I can always bring exponent down. This 3 is the base, so I want to change this is written in exponential form. I'm writing it in a logarithmic form. The base is 3, the base is always going to be 3. And this one here, which was a number, is the one that is supposed to be a 7 there inside. Therefore, my x here is supposed to be the same as log 3 of 7 and then plus a 1. Another thing that you can look at, if you don't like to leave it like this, I have a calculator here. Usually in the exam you don't have a calculator, so I can either say that looking into this is the same as log 3 of 7 plus. I want us to look into this law. Okay, let me just write it here. I don't have to go back there. If you look into this law here, it says that whenever I have a log a of x, I can always rewrite it as log some base b, x inside is the same as that, divided by log base b of a, right? So this base here becomes here, and then what was inside is still inside, but this base is a new base, but it must be greater than a 0. Now, I have a 1 here. How can I make sure that I rewrite this in terms of this such that when I'm taking this, I get a 1? So what I wanted to do here, I wanted to end up with a 1 here. The answer that I want a 1. In order for this and that to be equal, in order for this fraction here to be equal to a 1, I wanted this and that to be the same. So I wanted to end up having a log some b of some value here. I'm going to call this value maybe some c. As long as I have some value c here, and then divided by log base b, and then I have a c inside, this and that will be equal, and then I will end up having a 1. But if I look into this, this one here is going to be the same as this one. Usually is, if you look here, what is inside the denominator here, it becomes a base. What is inside here is still inside here, but we have different bases. So I want to rewrite this in this format here. I want to end up having a log, and if you look here, this is what is inside here. It must be a base because it's in the numerator. But if I take what is inside here, because this b and this b is the same, so I want what is inside there to be a c. What this means, as long as the number in the base here and that number inside here is the same, this log base c of c is supposed to be equal to a 1. That's what this thing is saying. Now, I want to have here a log, but this log that I want to have the same base 3, which means inside here I need to have a 3 so that I have a 1. The reason I'm using this base 3 here is because I want to end up combining these two with the laws that we already know. So that is why I chose the base 3. But if I chose the base 3 here, what is inside need to be the same as 3 like that, so that I end up having the 1, which is that 1. So here I will end up saying I have log base 3, and whenever I have a plus here, which means what is inside and what is inside can be multiplied, so I will end up having 7 times a 3, which is the same as I will end up having log 3 of 21. So that should be the final answer, since you don't have a calculator, which is a final answer. Whether you stop here or you want to write it cleaner like this, then you should be good to go. So that's what this thing is all it's actually all about. This one was number supposed to be number 4. So this is what we actually expect from actually this question here. And we can even test here what is the actual value here. Log 3 of 21 is 2.77, and if you look here, I can say 2.77 here. Let's say I have 3 raised to 2.77, and then I'm subtracting a 1. The answer I'm actually getting is closer to 7, as you can see, because I rounded off. But this is supposed to be the correct answer that we're waiting for. Someone else might decide to use ln on both sides. Doesn't matter. It doesn't really matter. Or just use a log on both sides. It doesn't matter. It doesn't really matter. Now, number 5. What is number 5 saying? Number 5 is saying we have log 3 of x is equal to 1 over 2. Of course, if you look into this carefully, you will find out that actually we have something that is inside here. We want to make it the subject of the formula. The base is 3. Whatever was there is supposed to be the exponent there. That's all there is to this. So the x is that, or you can say that it is the square root of 3, right? We can look into this like this format here. I'm gonna have log base 3, and then inside here I'm gonna plug in the square root of 3 and see what we are getting. We're getting half. So our x here is just supposed to be that. We are just interchanging this and that. Now, let's go to number 6. Number 6, starting from number 6 up to number 10, we wanted to use laws of exponents. So we have 5. We are not allowed to use laws of logarithm because the question is saying use laws of exponents. So we have 5 raised to 2x plus 1 is equal to 125. In other words, we have 5 raised to 2x plus 1. But we wanted to change this to be written having this 5 here as the base here, so that we can just equate the exponents. So here 125, if we divide it by 5, we will find out that we have 25, which is the same as 5 times 5. So this is going to be 5 raised to 3. Okay, 5 times 5 times 5, you will see that it is 125, which means now we have 2x plus 1, because this base here and that base is the same. So 2x plus 1 is supposed to be the same as 3, or 2x is supposed to be 3 minus 1. This was positive. Jumping the equal sign, it becomes negative. Or x is equal to 2. This is 2. Divide on both sides by 2, which is the same as 1. So that's what happened here. We had this, and then this is just 2, and then divide on both sides. So x is equal to 1. So if, let's say, I'm plugging 1 here, you will see that 2 times 1 is 1. 1 plus 1 is 3, which is that. So we get the same thing. Let's jump to number 7 here. Number 7 is saying that we actually have 2 to the exponent x minus 3 is equal to 1 over 16. Okay, here I already have a 2 here, 2 to the power x minus 3. Our job is to make this in terms of the base 2. So 1 over 16 is the same as 16 raised to minus 1. And of course, we're going to have 2 raised to x minus 3 is supposed to be the same as 16 raised to minus 1. But this 16 here is the same as 4 squared, or 4 times 4. But if you look inside, 4 is the same as 2 times 2 times 2 times 2. You get that 16. So we have a 4 here. And if you look carefully into this, you can even check it. 2 raised to 4 is the same as 16. So we're changing this 16 to 2 to the power 4. But now, if you noticed when we're dealing with laws of exponents, whenever you have a power of a power, this is the same as saying you have keep the base as it is, and then you multiply the exponents. So you just multiply the exponents. So here, this side I have 4 and minus 1, so I end up having 2 as that, and then I multiply the exponents. Here I have 4 and minus, so I will end up having minus a 4. This side I have 2 raised to x minus a 3. And if you look carefully into this, I have a 2, I have a 2, they are the same. So x minus 3 is supposed to be the same as minus 4, or x is supposed to be the same as minus 4 plus 3. Minus 3, jumping the equal sign, is supposed to be positive 3. So our x is the same as minus 1. So if you look carefully on this, you will find out that if I am plugging in here a minus 1, I will end up having a minus 4. You can check it if you want. So here our x was minus a 1, and then you minus a 3. What are we getting? 1 over 16, which means this is correct. So let's go to number 8. Number 8 is saying we have 9 raised to x is equal to 27 raised to x plus a 1. Now, if you look carefully on this, you will find out that the only option we have here, we want to change this to be the base 9 here. But we know that once I have 9 raised to 2, that's not 27, that's actually an 81. So what we basically end up doing here, we end up deciding that we cannot change this to be 27, we cannot change 27 to be in terms of 9. Instead, we can look for the factors of 9 and pick one of the factors and rewrite this in terms of those factors and this one in terms of those factors. So if I look at one of the factors of 9, we have the factors of 9 is 1, 3, and 9. So I'm going to pick 3 because 1 is not going to help us with anything. So I'm going to say 9 is the same as 3 squared raised to x. And then this side here, you will find out that 27 is the same as 3 times 3 times 3, which is 3 times 3 is 9, 9 times 3 is actually a 27. So we have an x plus a 1 there. And if you look carefully there, you'll find out that I use the same law here that a power of a power is the same as just keeping the base and multiplying the exponents. So I'm going to multiply these two. I have 3 raised to 2x is equal to 3, and then I multiply those 3 times x. I will end up having 3x plus a 3. This base and that base are the same, so I should have the same exponents if these two things are equal. So I have 2x is equal to 3x plus 3. And then of course what I'm gonna do is very simple. I am going to take I'm gonna interchange sides, which means I have 3x plus 3 is equal to 2x. When you're taking this whole thing, I'm just switching the whole thing. I'm not actually taking this to this side and this, I'm just switching this. So my right hand side is this and my left hand side is that. That's what I've just did. But even if you change the whole sign of this, you can still figure it out, it's still fine. And then I'm going to take this 3 to the other side, so it's going to change its sign. And then I'm going to take this sign to the other side, so it's going to change its sign. And then I have 3x minus that and then that. So 3x minus 2x, I will have x, and then that side I have a minus 3. So our x is supposed to be a minus 3. Let's do this and check what we're getting. If I have 9 and then I raise it to minus 3, what do I get? I get 1 over 279. And if I have 27 and then I raise it to minus 3, this is minus 3 plus 1. Plus 1. What am I getting? I still get the same thing here. This is that, and also I still get the same thing. So our answer here is actually correct. Now we are going, this was number 8. Let's go to number 9. Number 9 is just saying I have 4 raised to x plus a 2. This is equal to 8 raised to 2x minus a 2. Of course, the same thing here with 8. I cannot change this. I cannot change this to the base 4 because 4 squared is 16, not 8. So I cannot go that route. Someone might say, actually, we can actually do that. But let's not complicate our life here and just say that we're going to look at one of the factors here because the factors of 4 is 1, 2, and 4. But 4 is not actually helping us on this side. 1 is not actually going to help us. Let's use 2. So here, 4 is the same as 2 squared. And then we have x plus 2. And then this side here, we'll actually find out that 8 is the same as 2 to the power 3 raised to 2x minus a 2. 2x minus a 2. Actually, this was not a 2, it was a 1. Minus 1. And this one was 1. Yeah, I think that's it. Yeah, this is correct. And now if we look into this carefully, we'll find out that we use the same law that we're using, the power of a power, keep the base, multiply the exponents. So here I will end up having a 2 times x, I will end up having 2x, 2 times 2 I will have plus a 4. This side I will have 3 times that, I will have 2. 3 times 2 is a 6, so we're going to have 6x. 3 times minus 1, I'll have a minus 3. Now this base and this base is the same, so the exponents should be the same. So I have 6x minus a 3. Of course, I switch sides. I have 3x minus a 3 is equal to 2x plus a 4. Now, if you look into this, I take everything that has an x on one side, everything that doesn't have an x on the other side. So I will end up having 6x minus 2x. This was positive. When it's jumping the side, it's supposed to be negative. This one is negative. When it's going to the other side, it's supposed to be positive. So I end up having 4x is supposed to be the same as a 7. 4 plus 3 is a 7. And then an x here is supposed to be equal to 7 over a 4. And if we want to check things out, I want us to look into this. So I have a 4 here. I want to raise it to 7 divided by 4. And then I add a 2 here. So the answer that I'm getting, what was x here? 7 over 4, 7 over 4, plus a 2. 181 point this. Let's hope I didn't do anything wrong here. And then here we end up 2 times, I have 7 over 4. And then we close, and then we subtract a 1 here. If we subtract a 1, we still get the same thing. Also, the answer is the same. So our x is good. We're good to go. And now we have the last one, which is number 10. 2 to the power 3x is equal to 32. If you look at 32, with sometimes these problems become harder if you don't have a calculator. But to break this one down, you know that because we want to change this to the base 2. If possible, let's try. So this one is the same as 2 times 16, right? 2 times 16 is that. And if you look into this, 16 is the same as 2 times 8. And if you look into this, 8, 2 times 2 times 8 is the same as 2 times 4. And if you look into this, this is supposed to be 2 times 2 times 2 times 2 times 2. So we have 5 2's here. So we have 2 raised to 3x is supposed to be the same as 2 to the power 5. That's how you break this thing down to find out the number of 2's. 2 times 2, this one here, it is 4. And then this one here, it is another 4. 4 times 4 is 16, times this 2 is 32. So we have 5 4's. So this base and that base is the same. So our 3x is supposed to be equal to 5. And then, of course, our x here is supposed to be 5 over a 3. So that's supposed to be our x. We can test this. I have 2 raised to 3 times 5 divided by a 3. What is the answer? The answer is 32, which is that. So we are done. We have solved our x. Hopefully, this have brought some clarity on how to actually deal with these problems. Thank you.